All right. So another question from the topic of ray optics. I found this question to be very interesting, actually. Okay. And therefore, I picked this up. Okay. Let's discuss this. So what you can see in front of you is there is a lens. It is a biconvex lens. And then it is broken down into 4 parts, right? You have to find the equivalent focal length of the new arrangement. Okay. So before I start this, a quick overview of the concept. Okay. So if you have this lens, okay, like this, you cut it here. Okay. The only difference it makes if you cut it like this is the fact that the light intensity of the image goes down. That means the brightness of the image will go down, but the focal length remains unchanged, right? So focal length, no change. Okay. This is a focal length, no change situation. Let's talk about the second one. So this was a horizontal uh, bisection. Now let's talk about dividing this lens into 2 parts using this, right? So this is your vertical bisection. Okay. When you do this, you end up creating a lens like this, right? So which is like a plano convex lens. And if you do the calculation using the lens maker formula, what you get is your new focal length is double the focal length of the original full length. Okay. And so if you see the question, okay, what we have done here is we have divided this lens first vertically, maybe. So the focal length doubled of this part and this part, and then we split it horizontally, or we could do reverse, right? Let's split it horizontally first, right? So if you split it horizontally, we know there is no change in the focal length. But if you split it vertically now, the focal length reduces to double. Not reduces, it increases to double. So you end up getting each of this lens, okay, of 2f. 2f and 2f. Why? Because the focal length of plano convex is 2f. If you split it into 2 parts, the only thing that matters in a horizontal bisection is the intensity of light, nothing more than that. So the intensity of light decreases obviously because you don't have light coming in from both the sides. You just have light maybe coming from this side. So now so which means the upper part also has the focal length of 2f, just like a full plano convex. The half plano convex lens also has a focal length of 2f. Now you place them like this, right? So they're touching each other. It's a question of lenses in contact. Okay, if I have to find the focal length of the equivalent system, generally this is what I do, right? I do this is equal to 1 by 2f. I'm going to write for each one of them plus 1 by 2f plus 1 by 2f, and this is 1 by f dash, right? So 1 by f dash is 4 by 2f. So f dash is equal to 2f by 4, and the overall f by 2. Okay. This is the way you get the answer now. Although initially when I looked at the question, the feeling I got was that the converging power of this lens will go tremendously up because it is getting refracted 4 times, right? 1, 2, 3, 4. But in reality, this is the way you need to solve this question. The correct answer to this question is 2. Go to my playlist of ray optics. Don't forget to subscribe to this channel. You will see some very interesting questions that you can possibly expect in an exam. An excellent channel if you want to do practice of the questions and also want to understand the concepts of the physics. Thank you very much for your time and wait for the next video.